Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. AWS Elastic Beanstalk is Amazon's answer to teams that want the flexibility of EC2 and VPC resources, but without the heavy lifting of managing them directly. It provides a platform-as-a-service style experience. You provide your application code, and Beanstalk provisions and configures the infrastructure underneath. That includes EC2 instances, elastic load balancers, auto-scaling groups, and even networking integration. Beginners should imagine it as hiring a skilled contractor to build a house. You supply the blueprint, and they handle the materials, labor, and construction details. Elastic Beanstalk offers a balance between simplicity and control, giving developers a fast on-ramp to AWS while still exposing underlying resources for tuning. One of Beanstalk's strengths is its broad platform support. Out of the box, it can deploy applications in Java, .NET, Node, JS, Python, PHP, Go, and Docker. Each platform comes with pre-built configurations optimized for AWS. For example, a Python developer can upload a Django application, while a containerized microservice can run through Docker. Beginners should picture this as a multi-purpose kitchen. Whether you're baking, frying, or blending, the equipment is already set up and tuned for each style. The exam may highlight this wide language coverage as a key differentiator from narrower PaaS competitors. Beanstalk organizes applications into environments, and there are two main types: web server and worker. Web server environments run applications behind an elastic load balancer, automatically scaling EC2 instances to meet incoming HTTP requests. Worker environments are designed for background processing, often consuming tasks from an SQS queue. Beginners can think of the web server environment as a busy restaurant dining room, serving guests directly, while the worker environment is the kitchen staff preparing orders behind the scenes. Splitting these roles ensures each workload is optimized for its function. Deployment strategies are flexible in Beanstalk. Teams can choose all-at-once deployments for speed, rolling deployments for gradual updates, immutable deployments for safety, or full blue/green deployments for minimal downtime. For example, a rolling deployment replaces servers in batches, while a blue/green setup runs a duplicate environment and swaps traffic once validated. Beginners should think of this like renovating a hotel. You can shut it down all at once, upgrade room by room, or build a new wing and switch guests over. These strategies balance risk, cost, and continuity depending on workload sensitivity. Health monitoring is built directly into Beanstalk. The platform provides health checks for instances and a dashboard summarizing application status. If instances fail health checks, auto-scaling can replace them automatically. Beginners should picture this as a hospital monitoring vital signs. Green signals mean healthy, yellow suggests warning, and red signals serious issues. Developers benefit from immediate visibility without building custom monitoring frameworks, while still being able to integrate with CloudWatch for deeper observability. Configuration in Beanstalk can be managed through the AWS Management Console, the EB-CLI, or special .eb extensions configuration files placed alongside the application code. These files allow developers to customize environment parameters such as software packages, operating system settings, or logging paths. Beginners should think of EB extensions as post-it notes left for the contractor, reminding them to add specific fixtures or finishes. This balance between automation and customization makes Beanstalk flexible without overwhelming users with infrastructure minutiae. Managing application configuration often involves environment variables and secrets. Beanstalk supports environment variables defined per environment, making it easy to configure application behavior without altering code. Secrets can be injected using services like AWS Secrets Manager or Parameter Store. Beginners should see this as a recipe with placeholders for ingredients. The recipe stays the same, but the specific values change depending on the environment. Separating code from secrets enhances security and simplifies promotion from development to production. Logs and monitoring are integral to Beanstalk's value. Logs can be streamed to CloudWatch logs or downloaded directly for inspection. Monitoring integrates with CloudWatch metrics and alarms, allowing administrators to trigger notifications or scaling actions. Beginners should think of logs as the black box of an airplane. Even if the system fails, the record of what happened remains available. In Beanstalk, developers don't need to stitch together monitoring. It's wired in by default, yet still customizable. Database integration requires careful planning. Beanstalk allows attaching an RDS database directly to an environment or connecting to an external RDS instance. While attaching is convenient, it ties the database lifecycle to the application environment, complicating upgrades or redeployments. Best practice is to externalize the database, keeping it independent. Beginners should imagine attaching a garden directly to a rented apartment. When you move, the garden disappears too. Externalizing the database ensures persistence beyond application lifecycle events. Security in Beanstalk relies on IAM roles, instance profiles, and security groups. Each environment runs EC2 instances under an instance profile, which grants permissions to interact with other AWS services. Security groups act as firewalls, controlling inbound and outbound traffic. Beginners should picture these like office badges and locked doors. Badges grant access to certain areas, while doors keep unauthorized people out. Correctly configuring IAM roles and security groups is essential to prevent overexposure while enabling application functionality. When creating a Beanstalk environment, VPC configuration choices are made up front. You can deploy into the default VPC or choose a custom VPC with isolated subnets, NAT gateways, or private routing. This decision affects security, connectivity, and cost. Beginners should think of this like choosing a neighborhood for a new house. The location dictates schools, safety, and utilities. Once deployed, moving environments between VPCs is complex, so planning carefully at creation time is critical. Versioning is built into Beanstalk's application lifecycle. Each uploaded application bundle becomes a version that can be deployed, rolled back, or promoted to other environments. This enables safe experimentation and recovery if new versions fail. Beginners should see this as publishing new editions of a book. The library keeps every edition, and you can always bring an older one back into circulation. Versioning provides confidence for developers to deploy changes without fear of irreversibly breaking production. Cost in Beanstalk follows a straightforward model. There is no extra charge for Beanstalk itself, only for the underlying resources it provisions. That means EC2, ELB, autoscaling, and RDS costs still apply. Beginners should picture Beanstalk as a free project manager. You don't pay for their services directly, but you still cover the cost of the workers, tools, and materials they organize. This makes Beanstalk attractive for teams who want orchestration without additional overhead. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Elastic Beanstalk integrates naturally with continuous integration and deployment pipelines. Services like AWS Code Pipeline and Code Build can compile code, run tests, and deploy the latest version directly to Beanstalk environments. This removes manual steps and ensures consistent, repeatable deployments. Beginners should think of this as a printing press. Once the manuscript is ready, it moves automatically from draft to published edition. CI/CD integration brings velocity and reliability, two qualities that modern teams need when delivering applications quickly while maintaining quality. Auto-scaling in Beanstalk mirrors what you'd configure manually in EC2, but with less effort. Each environment can define scaling policies so that additional instances launch when CPU, request count, or other metrics rise. When traffic falls, instances terminate gracefully. Beginners should picture this as a store hiring temporary staff during peak shopping hours and sending them home when business slows. Auto-scaling ensures applications remain responsive without overspending, letting developers focus on code instead of infrastructure. Rolling restarts and zero downtime cutovers are supported deployment patterns in Beanstalk. For updates that require replacing servers, rolling restarts refresh them in batches so the application remains online. For maximum safety, blue/green deployments spin up a parallel environment and switch DNS records only when the new version passes health checks. Beginners should see this as hosting a concert rehearsal in a second hall while the original show continues. Once the new performance is ready, the audience is smoothly redirected, with no interruption to service. Blue/green deployments in Beanstalk are made easier through CNAME swaps. Each environment has a unique CNAME, and flipping traffic between old and new environments requires only swapping these identifiers. This reduces the risk of mistakes and avoids DNS propagation delays. Beginners should imagine switching street signs between two parallel roads. The cars simply follow the updated sign and traffic flows seamlessly. This simple mechanism makes blue/green deployments accessible even for teams new to AWS. Capacity right-sizing remains a responsibility in Beanstalk. Developers must choose the underlying instance types and sizes for each environment. Selecting too small leads to sluggish performance, while over-provisioning wastes money. Beginners should picture this as picking chairs for an event. Too few and guests stand uncomfortably, too many and you've overspent on empty seats. Beanstalk abstracts infrastructure details, but wise choices about instance families still shape cost and performance outcomes. The worker tier is a distinctive Beanstalk feature. It provisions an environment tied to an SQS queue, pulling messages for asynchronous processing. This is ideal for background tasks such as sending emails, generating reports, or resizing images. Beginners should think of it as the kitchen in a restaurant. Orders are placed in the queue and workers handle them steadily behind the scenes. Worker tiers free web servers from background jobs, improving responsiveness and throughput. Managing multiple environments is a best practice with Beanstalk. Teams often maintain development, staging, and production environments, each with its own configuration. This separation allows testing changes safely before promoting them to production. Beginners should see this as quality control in a factory. Prototypes are tested on a smaller line before mass production begins. Multi-environment strategies reduce risk while supporting agile, iterative development workflows. Security hardening is necessary even in a managed service. Developers should assign least privilege IAM roles to instance profiles, patch application dependencies regularly, and restrict inbound traffic with carefully scoped security groups. Beanstalk simplifies operations but doesn't remove the need for vigilance. Beginners should picture this as locking doors in a rental apartment. The landlord provides the space, but you are responsible for securing it properly. Security responsibilities in Beanstalk still follow the shared responsibility model. Observability is enriched by Beanstalk's integration with CloudWatch. Metrics such as latency, error rates, and CPU utilization can be displayed in dashboards or tied to alarms. When anomalies occur, alerts notify teams so they can respond quickly. Beginners should think of this as a security system with sensors on every door and window. Even if the system is simplified, monitoring ensures visibility, accountability, and trust in the application's health. Cost controls in Beanstalk depend largely on the choices made for underlying resources. Running smaller instances, scaling down outside peak hours, and turning off non-production environments overnight all reduce expenses. Beginners should picture this as turning off lights in unused rooms. It doesn't change the architecture, but it prevents waste. While Beanstalk doesn't charge directly, cost efficiency is still an ongoing practice tied to how environments are provisioned and used. Comparisons with other AWS services clarify Beanstalk's niche. Unlike ECS or EKS, which require deep knowledge of container orchestration, Beanstalk abstracts most infrastructure choices. Unlike Lambda, which requires event-driven designs, Beanstalk suits traditional web apps with long-running processes. Beginners should think of it as the middle ground, easier than orchestrating containers, more flexible than serverless, and more opinionated than raw EC2. The exam often highlights Beanstalk as the answer for teams seeking a managed PaaS experience without rewriting applications. From an exam perspective, Beanstalk is framed as a platform-as-a-service solution that provisions infrastructure automatically but leaves knobs available for customization. If the scenario emphasizes upload your code and AWS provisions EC2, ELB, and auto-scaling automatically, the correct answer is Beanstalk. If it emphasizes container orchestration or serverless events, ECS, EKS, or Lambda will fit better. Recognizing this distinction saves confusion when multiple services appear as options. In conclusion, AWS Elastic Beanstalk accelerates deployment by abstracting infrastructure setup while still preserving AWS's control knobs. It supports multiple platforms, handles scaling and monitoring, and offers deployment flexibility through rolling, immutable, or blue/green strategies. For learners, the takeaway is that Beanstalk represents the easy button for deploying traditional applications on AWS. It removes friction, reduces manual setup, and supports growth, but it doesn't eliminate responsibility for right-sizing, security, or cost management. Used wisely, it offers a balance of speed and control that bridges the gap between developer ease and AWS's powerful ecosystem. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.